Okay, so let's say you meet this question in a test or whatever, and it says, it's problem 5, right? It says a parallel plate capacitor has blah, blah, blah. The plates are separated. The moment you see it's about capacitance, you go to your capacitance formulas. Now I'm going to remind you, you need to be good at this. I know you are now probably good at it. Capacitance, we said how many? We have 4. Number 1, it's 2 for E, okay? E is sigma over mu 0, okay? Then we say that E is going to be equal to delta V over D, okay? I'm remembering this, so you should remember it. I know you can because I can. Okay, I'm testing with myself. If I can, then you can. So sigma is because you are the ones writing. Okay, Q over A, which is, remember, sigma is just charge density, so it's charge over area. Then now we go to the third, which are for capacitance itself. So capacitance, we know that it's Q over delta V, the very first one. Okay, then the other ones are easy. Capacitance is mu 0 A over D. Then this is if there is no dielectric, if there's just air between the two capacitors, then here it's K mu 0 A over D. This is the other one. Then finally, we have the fourth formula, which is now going to be for the energy stored in a capacitor. So we say energy, we use one of 3 versions and we just write them together. Either it's half Q delta V, or it's half C delta V O squared, or it's half Q squared over C. These are the formulas for energy, and we are done. Only this? Yes, only this. So let's choose one. Okay, so what are they asking us? Capacitance of device. Okay, so we come to these formulas. Look at how easy it is. You come to these formulas and choose the one which works for the situation which you have. Okay, what is the situation which we have? They say that we have a parallel plate capacitor. The plates are separated by paper. This thickness of paper, not air. So that means there is a material, there is a dielectric. So we are going to have to use this one, okay? We are going to have to use, okay, we said one of the 3 for capacitance, but specifically this one because there is paper. There is no air in between. There is paper. So I'm going to say A is going to be capacitance is equal to K mu 0 A over D. So that's, I just have to find these things, okay? What is my K? K is given here. K is for paper, so I have to be given it. Here it's 3.7. Then it's going to multiply. We say 3.7 by, let's put the for the capacitance now. Mu 0. Mu 0, it's 8. You can have it on your constants if it's in the test. 8.85 times 10 to the negative 12. This is Coulomb squared Newton per Newton per meter squared, okay? And then we are going to multiply by A over D. What is A? Remember, here they say the plates is the area, of course. The plates have 2 centimeters by 3 centimeters. I know what centi is. It's times 10 to the negative 2. So it's 2.0 times 10 to the negative 2 meters times 3.0 times 10 to the negative 2 meters. This gives me area. Remember, area of a plate, it is length times width, which is these 3, okay? Then I'm going to say divided by now the distance between the 2 plates. They say the plates are separated by 1 milliliter. So milli is 1.0 times 10 to the negative 3 meters. There we have it. Now we can just put it in the calculator and get a solution. How easy is that? Remember to convert to SI units. Remember to convert to SI units. Okay? And once you do it step by step, of course, when you're calculating. This is, you first get the answer for maybe these 2 here. These ones. Okay, then you divide by this. So you say 2.0 exp negative 2 times 3.0 exp negative 2 times 10 to the power of negative 2 is exp in your calculator, exp negative 2. You get an answer. You say divided by 1.0 exp negative 3. You get an answer. You say multiplied by 8.85 exp negative 12. Okay, you forget the units. You just put the numbers. 8.85 exp negative 12. You get it. Then you say times 3.7 again. You're going to get 2.0 times 10 to the negative 11, okay? And if it's capacitance, it will be in farads, and you would be done. This is going to be what it is, okay? How good is this? Very nice, isn't it? All right, so this is going to be the first solution.